Thank you so much for having us here today. If you don't mind, we'd like to ask you some questions. What field of science do you work in, and how long have you been doing it for?
I'm a climatologist, and I've been working on climate change related issues. I've been working on this field for about 20 years.
What tools do you use to understand and study the variability and extremes of climate?
The tools we use is, first of all, we need to understand, we need to define a way so that we can quantify what are the variabilities and what are the extremes. Once we are able to quantify these values, then we use different kind of statistical method to identify if there was any changes in this kind of variability and extremes. And after that, we will try to compare what we see in the observations with what computer model might tell us, for which that has been driven by what we consider to be external forcing or external influence to the climate system, such as carbon dioxide emissions by human activity.
So, what are some general trends and patterns you have noticed over time?
Well, there are many kind of consistent changes we actually see in the climate. For example, in Canada, what you are more interested, maybe polar bear. You know, polar bear need to live on ice to catch fish or seals. And what we see in Canada is quick decreasing or a reduction of sea ice. We have quick loss of sea ice. That is one of the kind of change we see. You see, when you have this kind of increase in temperature, you can imagine that you will have less sea ice, right? Because it's hotter. That's one kind of change we see. Another kind of change we see in Canada is we have much higher temperature now than 40 years ago. 50 years ago, the Canadian temperature is about more than 1.5 degrees higher than 50, 60 years ago. That's another change we see. And also in Canada, especially in northern Canada, we see quite a bit increase in amount of precipitation in snow. So actually, if you go to north, you do see much more precipitation or snow there. That's another kind of change, another kind of pattern we see. And then if we go to the west, if you are a farmer, you would notice that the water from the mountains, due to the melting of snow getting earlier. That is because now it is warmer, so the snow melt also starts earlier. If you remember that a few years ago, sometimes you may not have enough snow to ski because winter was so warm. So in general, if we look at Canada, we see many things actually occurring at the same time. Everything is consistent with increase in temperature. That's what we see from Canada. Globally, what we see is an increase in temperature everywhere. And then we see the changes in precipitation. But this kind of change is a little bit more complicated. Change in precipitation is different from different places in the world. Like in Canada or elsewhere in a higher latitude of northern hemisphere, we see increase in precipitation. In the mid-latitude, we actually see decrease in precipitation. These are all consistent with what we expect from increase in greenhouse gases. And the other thing that we see is the increase in the humidity. You know that the amount of water that air can hold has something to do with temperature. So in winter, you see that the windshields get kind of condensed very quickly. Sometimes you have lots of fog on the windshield because it's cold. However, in summer, it's very rare to see that. That's why, because when temperature is higher, the air can hold more moisture. So with this kind of global warming, we also see much more moisture in the atmosphere. When you have more air, when you have more water in the air, when it rains, it will give you much more rain. So that's also a kind of change we see.
Did your recent report, Human-Induced Arctic Moistening, yield any interesting findings or results?
Okay, that report itself is very interesting in that we were first to demonstrate that human activity has actually contributed to the increase of precipitation in the northern high latitude. This is a kind of things that we have been expecting from climate model simulations or from climate model studies and from theoretical expectation or from understanding of how moisture, how atmosphere will react to the increase in temperature. And it was also what we see in the observations or amount of precipitation measured in different parts of northern high latitude. But we were the first actually piece together between what we see in observations, what was expected in the theoretical work or the model simulations.
What's a climate change indices and how's it used? And also, what's your involvement in developing it?
Well, climate is a fairly complicated thing. It is not something that we can put a lab that we can experiment on. And it is so complicated that we even don't have a complete observation covers every aspect of climate. So, but still we need to study it. The indices are the kind of things that we develop such that with this kind of indices we can measure, we can quantify different kind of aspects of changes in climate. That is, if you want to know how tall is some person, you need to have a meter or you need to have a tape. So this kind of indices are different kind of metric that we use to quantify different aspects of changes in the climate. We helped the World Meteorological Organization to develop a suite of indicators that can be used to quantify changes in extreme weather and the climate. And this set of indices has been used in all countries. So what we try to do is we help different countries, especially relatively poor countries, where they have smaller capacity in doing their own research. We help them to use our indices such that when they do their analysis, then their analysis can be matched or can be pieced together with people doing similar analysis using our method indices in different parts of the world. So essentially it's somebody draw a map for China, somebody draw a map for India. When we have both India and China work together, we get a map that actually matches along the border. That's the kind of thing we try to do. So by doing that, we can have a global coverage. That's why we can see changes of this kind of extremes in different parts of the world. Okay.
If you had the attention of the delegates at the upcoming United Nations Framework Convention on Climate Change in South Africa, what would you like to share with them about your current research?
Well, there are a couple of things that I think everybody needs to really understand. One is climate change is real, and that is mainly caused by anthropogenic influence. For that reason, we need to do two things. One is that we have to try to find a way to mitigate such that we reduce our human emissions of greenhouse gases to the atmosphere. However, this is not good enough because anything that we do now will only have impact for much longer term, which means that it's not immediate because we have already put too much greenhouse gases in the atmosphere. The warming will be there for many years, for thousands of years. Therefore, it is very urgent for everybody to think about how to adapt to the changes in the climate. So you really need to think about what you can do in order to reduce the impact of climate change on you or on ecosystems. The third thing I think people need to understand is that we do need to have fairly good mechanism to exchange information and data, because that's a way that helps scientists to have a better understanding of what's going on and what might be the future of climate. And that itself will help to make a more informed decision about adaptation to the changes in the climate.